Welcome everyone. Thank you for joining us for today's expert webinar titled Generative AI with Large Language Models. I am Ria from SpringPeople, and we are India's largest enterprise training provider. And I will be your moderator for today's session. In today's session, we have Global Certified AWS expert Mr. Rajiv Chandran, a distinguished technology luminary with nearly 2 decades of industry-leading experience, who embodies the essence of a visionary leader and architect of cutting-edge solutions. Mr. Rajiv Chandran has laser-focused expertise in data science engineering, ML and AI solution architect, big data solution architect, software engineering, AWS solution architect. Rajiv has left an indelible mark on the e-commerce, retail, search, and advertisement sector. In today's webinar, Rajiv Chandran will let us know about AI and GenAI, NLP and word embedding, LLM models and types, LLM use cases, foundation models and GPT, transformers, developing GenAI app, frameworks, LangChain, Llama indexed, prompt engineering, retrieval-augmented generation, RAG, fine-tuning, vector databases, LLM-As-A-Service. To all the participants, you can mention your questions in the chat box, and it will be answered at the end of the session. Without further ado, let's start today's session. I would like to invite Mr. Rajiv Chandran to start the session. Over to you, Rajiv.
Yeah, thank you, Ria. Good evening to all. Extending a warm welcome for the session. Thank you for your presence. I'm Rajiv, as Ria introduced. I am a consultant for generative AI and also doing a bit of research related with Microsoft's foundational models. And my specific focus has been doing on the AWS stack for generative AI. So with that introduction, let's get started. So we look at what we'll understand what itself is to understand what itself is artificial intelligence, and then we take on a sequence journey towards understanding what LLM itself is. Okay, so the idea of machine that thinks date back many centuries. Everybody wanted to know. It started with machines that can calculate, and then once that got into a mature state, then everybody wanted to think about whether you could actually have machines that can think. So this is an idea which dates many centuries, I should say. So what's artificial intelligence? It's a technology that enables machines to simulate your human reasoning and problem-solving capability. So you want this in your machine, and that's what is your artificial intelligence. Also, replicating other activities more than the human, human brain itself. So you would want you want to just mimic everything what a human does into a machine, and that actually constitutes your artificial intelligence. Okay, now they've kind of organized or categorized this artificial intelligence into kind of 3 categories: narrow, general, and super intelligence. The narrow intelligence has been in works for quite some time now, maybe the last 50-60 years. While the super intelligence is, the general intelligence, which means that you have machines that are in capability with equal to a human. So that's still in work. It's a work in progress. Probably in the next 5-10 years, maybe. And super intelligence, I think it's a bit of hypothetical concept, I presume. I'm not sure, which is supposed to be more than what humans are. I mean, I'm not sure whether we may get into that stage, but yeah, you have a concept like that as well. Now, So if you look at how the whole idea evolved from for this artificial intelligence, it's actually a constituent of some machine learning, deep learning, and this subject called NLP, which is our actually focus for the day. So that what actually constitutes your artificial intelligence. You have all of this together, and then you can create everything. You could literally replicate everything what a human does. Okay, so what's machine learning, deep learning, and neural network? How do you want to look at this whole idea? I mean, I'm sure we've been repeating these terms a lot, but let's look at it from a little slightly different perspective. So, what's machine learning? At its core is just a statistical model that can we use the word learn, and then it can once it's learned some pattern or feature. Then it can, and you later send some data, it is able to, generalize on that unseen data. That's all. It's basically a statistic stuff and nothing more complex than that. Then what's neural network? Now, neural network is a way you've organized your processing inspired by a human brain. And what do you do with this neural network? You solve statistical problems with this while you're laying out your whole, while you compute your process like how your human brain does. That's all is your neural network. And when you look at deep learning is again machine learning. It's again machine learning, but you solve problems with multiple layers of machine learning. So deep learning is just multiple layers of your machine learning, and with these three concepts and from concepts and having this in a mathematical and in a computing idea constitutes your AI. So this is so your machine learning is all about these terms that I'm sure you have heard of. The way of learning, or is like you have something called a supervised way, unsupervised way, and there is this idea of reinforcement learning. So human also learns using these kind of patterns. Okay, so then what's NLP? Now, which is the focus area for this particular session? So NLP is all about, first of all, it's a subject which has been there for the last 80 plus years. This is that very subject which actually has led into this idea of generative AI. It's NLP. Now, within NLP, the NLP is largely about, if you take, let's say, a word editor, which is nothing but an application, but means it's just an algorithm. In its present form, you take MS Word, it doesn't even understand whether it is a character or a word or a sentence or a paragraph. It just doesn't understand. You will have to enforce some rules for it to understand. Now, NLP is an attempt to create some mathematical models using computers such a way that this text, which you can lay out in a word editor, can be understood by the machine, and you can then also be able to generate text, understanding and generating. And that idea is NLP. Apart from many other things that we do, we look into it. So what do you want to do from an NLP? Once you have a text, you want to do a text generation, you want to do sentiment analysis, text mining. There are various things, and one of the most very interesting concept, translation, right? You want to do this. So there were many attempts starting since the 1940s, where the earlier ideas were all around using rule-based approaches, statistical approaches, and then early stage machine learning models. However, it was in the early 2010 when we had the first or an inflection point occurred, where we have and this happened within Google, and they adopted deep learning as a way to generate and understand a language. And that inflection point is what today have led to this idea of generative AI. And 2010 onwards, and then there's another point near 2017, which was transformational, and there was no looking back after that. So that's why we have this idea of doing what is natural language processing. Okay, word embedding. So what is word embedding? Now, word embedding, as I was see the way if there was no, I mean, in the present way, when you organized text in your machines or in your computers, it's all about using some kind of representation, ASCII characters, or the other forms of Unicode and things like that, right? That's how you represent. But these are only representation. Means I can't, as I told you, I can't do any understanding, or I can't even generate. So if I would have understood, I could have generated. So there were enough attempts being done on the space of word embedding through statistical and or even various forms of machine learning way to understand. So word embedding is a concept that helps the computer, helps a computing machine to capture the semantics and syntax and the syntax of that particular text, a text document, whatever that may be. And this revolution kind of, I mean, or the inflection point happened around 2010, where this was done through a deep learning way. So that's your word embedding. So word embedding is where that transformational journey starts. And it's not that word embedding did not exist before, but the word embedding through the idea of deep learning is where that transformation starts. So as I said, there were various forms of word embedding that existed, from statistical form and other forms. And this is the deep learning form, and then we get into the idea of the GPT way. So we look at that. So when you transform a text into a word embedding format, and you were to represent that and you want to kind of visualize, it would kind of appear more like this. So there is this quote which says, you shall know a word by the company it keeps. So what happens is, because we have to capture semantics and syntax, then you had to do a lot of kind of processing to get into this idea of how to understand text, and then much later how you're going to generate the text. Okay, so word embedding is that particular text stack, a combination of mathematics and computing, DSA, data structures and algorithm, which has got into this particular stage for us. So then what's generative AI? Okay, so generative AI, generative artificial intelligence, is an algorithm, I should say, a mathematical model, an algorithm, which is capable of generating, and I said this again falls into that idea of NLP. This is NL generation, understanding and generation falls into that space where it can generate text, images, or rather anything that you can visualize within your computer. And these models learn a lot of patterns, structures of their training data, and then generate a new data. So as much as a human needs to learn, read a lot, if he has to start writing something. So when you do research, right, when you do research and you want to write something on your own, it can only happen when you've read so much, and it's from that data that you've read and memorized is where you're able to start generating. So generative AI is that a model, algorithm, which can do all these. So if you look from the whole perspective where generative AI, it is nothing but a deep learning model embedded in the NLP's in the NLP stack. That's your generative AI. Okay, now how do you differentiate this between this generative AI and your traditional AI? Now, this is something which everybody kind of are curious about to know. How do you differentiate? And why do you even use this idea called a traditional AI? So, yeah, AI as such, I mean, since the age of digital, of anything, yeah, images, text, etc. We had always some form of rudimentary AI. It always existed, but to make it generative is where that a big step happened a little later. So in the traditional analytics, you can, you do your general predictive analytics, fraud, image recognition, topic recognition, all of those things which are happening now. They are not generative, right? There is existing data, and from that existing data, you are interpreting something. That's your traditional AI. But whereas generative, it's not only interpreting what is there, it is understanding, and it is able to generate. So that's where you differentiate, and it can generate any kind of data, be it image, be it normal text, or in some graphical way. There is nothing that it can't generate, as long as you are able to feed in the data through which it can learn some patterns, inputs, and from that inputs, it's further able to do some probabilistic calculation to generate an interview. Eventually, I mean, it's all about predicting the next token, or even a pixel, right, in an image for the next idea that you have. So that's the difference. Okay, so now what's foundational model? Okay, so let's look at. So foundational models are nothing but large are deep learning models that have been trained on large data, large data, a lot of different kinds of data. And again, we will look at, there are different kinds of foundational models. And in our case, now this has been, if it's a foundational model, we are in today's session, we are talking, it's been trained on large number of text, generic, very generic text, large amount. And after this has been trained, now what's important about the foundational model? The foundation model is that perfect NLP that I'm talking about. It can understand and it can generate. So that's where you differentiate it from the traditional AI. So this is what it is all about. You give any kind of data, a text, any kind of unstructured data, voice, video, audio, whatever may be, and I do a training, or I would say do a learning. Once the model has learned, then it is able to generate. We can categorize foundational models. So we always hear about the word large language model, but it's just not large language model. So there's large language model, there is large vision model, audio model, and when you combine all the three, you get the multimodal models. So foundation models are focused in doing a particular job. And now the other interesting aspect, which you will see in the following slides, is to see how else can you use foundation models. So there are a large number of foundation models that presently that are being developed for various tasks that you may you think you want to get assistance from. So the large idea is, to get assistance from past data in various ways, as much as your analytics would have done. That is your descriptive or predictive analytics. But here I'm looking at just not forecasting, but also generating in various ways. Okay, so then what are large language models? Very simple. I think we got the answer to that in the previous slide. So language model is any type of machine learning model trained to conduct a probability distribution of a word. So it's in a simple sense, if you take if you take English language, there is the certain number of vocabulary that you have, maybe a million or so, whatever that may be. And when you get a sequence of text, when the computer is being given a sequence of text, then it is able to generate the next text, pretty much like what you see in your search. It is able to generate the next text based on a probability which has been learned over various other texts that it's gone through. So a large language model means it's about all text. That's the idea here. So but basically just predicting the next text. That's all it is. A language model, so large language model is a deep learning algorithm that are trained on massive amount of text data, and as a result they can generate a coherent, fluent text as much as a human does, and you would as much as feel that you are interfacing onto with the human as such. So that's the large language model. A kind of work started on this. So this is core NLP, working language models, and then getting into the idea of large language models is the initial start on this whole idea of generative. It starts from this whole journey, and then it goes forward. Okay. Now, what are transformers? So this is that algorithm, that mathematical model which has transformed into this world of generative AI. So first of all, what's transformers? So transformers are deep learning models, which are the fundamental building blocks of not only LLM, large language, it's LVM, LAM, LLM, large multimodal models, everything. At its core, transformers use a mathematical technique implemented, of course, in an algorithm to get this idea of self-attention. So what it means is, in a very simple layman's language, when I talk about the word, say, a bank, now for the system, now first of all, it doesn't even know there is a word called bank, but through this idea of it's a combination. Transformers are just not a single layer of stack. It's a combination of having your vector embeddings. There are a few other things called positional algorithms and few other things which are combined together to get what is called as self-attention. So self-attention is the idea of getting a context from that sentence or from that paragraph, etc. This is how when you look at the idea, when you've read a book and you summarize, that is what your transformers is able to do. Again, much like the word to vec, which originated in Google, this is also a work that was that originated in Google, and then there's no looking back. And it went on to transform the way we are looking at it today. This is the kind of an architecture that it looks something like a electronic circuit, but that's not the way it is. It's a neural network. It's a neural network. It's a deep learning neural network, organized it in a mathematical flow. So a neural, there's a map and there's a neural network around it. That's all it is actually, and all about it is going back into doing something in the NLP world. Then later applied across. So this started in the language processing, and then it got evolved into various into your vision, and then and audio and various other models. Okay, so what's GPT, which is the word that goes around, chat GPT, right? So models developed using transformers, and in the transformer there was this concept of encoder and decoder, which is there otherwise also. These are not new things in terms of processing in the in the image world, but it uses one of those stack and are specifically trained for, but this GPT is purely trained for text generation. Okay, these types of models are referred to as generative pre-trained transformer, and ChatGPT is one of it. Okay, of course there are many that have come further to that, and that's the idea of GPT. Okay, so use cases, and this is a list, I presume, that is never going to end anytime soon. It's like saying that whatever a given human does a task, the various tasks. If you could list down all the tasks which I mean, not the mechanical and thing, which are being used from an intellectual pursuit, all of that can now be captured as a use case. So you can do this for your customer experience, various kinds, virtual assistants, personalization. I mean, of course, you folks have definitely experienced a lot of these things. And then for employee, it's a sample use case that I've just put across here. Creative and content. So like to just quote an example of what Adobe gave. Adobe says that, if I have to create a flyer, create some marketing content, now I would get 10 ideas, staying out, thinking it over a week. Today with generative AI, I'm able to get 100 different ideas within the same period of time. So that is how it is. It's helping as an assistant. Yes, you can of course get into it. I mean, you could literally create a film. You can literally create film with very realistic looking characters, or rather, when I say very real, it's a realistic looking characters, I should say. And you can actually, including the script writing, everything can be done today using a large language model. But the compute resources is what constraints in a big way for a lot of people, and your business operations as well. So all kind of banks today have evolved I mean, banks have started adopting this in a big way. Now, the classic case of the bank is, I don't know whether you've heard of this. There's this Bloomberg, which created Bloomberg GPT. It's, I mean, it's nothing but, an assistant for your investment, right? You can actually literally, you have, you can actually talk to it as if your investment advisor, much like and there are no, it's not going to have any kind of bias. It's so well organized in that sense. Okay, so what next? Now that we have seen that there is a product called your a generative AI or a foundation model, the product outcome of this whole exercise is a foundation model, right? And you saw there is various kind of foundation model. So the next step is, now that you know all this, how can I adopt it for my organization or for your client, and what processes can I address that will help it improve those particular tasks? And that's what we want to see. So now the next part of this is understanding how I could develop applications using generative AI. So as usual, you kind of look at your use cases, and then you need to find out what models that are available, and then as a next step, how would you adapt that particular model for your particular use case, and then integrate it into your app. So that's how we're going to start developing the model. So the first thing that you want to know about when you are going to build your model is which foundational model to choose. Now you see there are at least 1,000+ foundation models created by various organizations, and I'm sure you already know a few of it on your fingertips, starting from which is I mean, of course, leaving aside the commercial version, I'm talking of the open source version, llamas and the whole other, the 5 series and various Mistrals, various kind of foundational models. Now, one of the interesting aspects of the foundational model is what task it has to achieve. See, now let's take an example of let's say a a llama, a general llama. I'm not looking at a foundation model which have been trained on text on internet data. Now, can that model, I'm helping you to understand how would you choose a foundation model? Can that model help me do mathematical reasoning? Okay, can it do that? Or can it help me design a new protein? Now now, with this query, I'm also looking at I'm looking forward to an answer whether these models are domain specific. Models are domain specific. So you will have to go through finding out what model is good for you. A pure text generation model like your llama is not great for generating your code. So they have released this idea of code llama, and then now they're also trying to release or rather they released, I think, for a foundational model for the embedded systems and things like that. So the whole foundation models can change. So now I'll give a classic case. So let's say you have let's say an Indian organization wants to, maybe Mahindra wants to design their cars, right? And they start with the design. Now, if Mahindra wants to use a generative AI to create new designs, then they will have to create the foundation model that's very specific. Okay, so foundation models are specific. So in that case, now you will have to evaluate whether to get an existing pre-trained model to solve my problems, which may be the case in 60-70 cases, or would you have to customize the LLM? So that's the thought. That's the thought, and the cost involved in this is what everybody wants to know. So there are now strategies for developing your AI. You will look at whether you want to reuse an existing LLM, or do you want to adapt an LLM for your particular use case, or you build something new. So these are only the choices that you have if you want to integrate your foundation model into your app, because this is a very specific case, and then you need, right, I mean, for a business, the level of accuracy must be similar to human and experienced human intellect, right? You can't have it in a juvenile state. So that's very important. So you would need to very clearly decide what is that you want. So once you know, then you can of course do what this idea of there are various methods. We look at what those methods are to adapt your foundation models. Okay. So the stack, I mean the technical implementation of adapting are various formats. Okay, there is, I'm sure you've heard of this word, prompt engineering, and then there is the other big idea called RAG, which is one very popular stuff, and then there is this idea of fine-tuning. So we look at each one of them. So as you might have now clearly understood, foundation models have limitations, not limitations because they have a limitation per se. It's about the data that you have fed into it. And of course, design also matters. The algorithm, the mathematical model that is part of it. So it all decides how you want to, how your learning is going to be. The idea is what every foundational model should be able to reason and do problem solving, and for these two you would have to go through various mathematical models as well as algorithms, right? So the easiest way to check if a foundational model solves your problem is through this prompt engineering. So prompt engineering is all about a carefully crafted text you input into the LLM model, and then you see whether the expected outputs are as per your expectations. And I told you this have to be an experienced human intellect quality. It can't be juvenile. So that's your prompt engineering. Now this is a bit, I mean, it's a bit a laborious process because you may have to craft various kinds of prompts. Now for this itself, now what's happening is it's pretty interesting. It's a kind of a chicken and egg kind of a situation. Now to generate prompts, I may have a foundation model itself. It's like that, because it's not easy sometimes to get clear, to give proper prompts to get a suitable answer. And you can't tell when the client is in the other side that he or she has to speak only in, I mean, only has to input in specific way. The individual will generalize, right? And so your prompt engine, so the prompts have to be as much as more of human instruction to get the data out. So this is the first way to check if you are good enough with that. Then the next step is, if you find that a prompt engineering is not helping you, you do what is called as fine tuning. So fine tuning, it's a way to add domain specific data sets, and then you get a better foundational, or you get an adapted foundational model which suits your specific domain and for that specific organization. But here it's among all this, see, whether to choose a RAG or a fine tuning or a prompt engineering, it's all a cost consideration. So prompt engineering is the cheapest way to go about doing it, while if you look at fine tuning, there is a cost involved, there is time involved there. But anyway, relatively small amount of time, maybe anywhere between, you may end up running your whole algorithm for 8 to 10 days or something like that. Okay, and RAG. Now RAG seems to be a better option compared to the extremes of it. Prompt is in one extreme, prompt engineering, fine tuning is in the other extreme, because fine tuning entails that you do some learning process, right? RAG is you use your existing model. However, you inject domain specific data into a database, and when you are doing a generative stuff of it, the RAG, retrieval-augmented generation, it actually collects the data from both the learning from the algorithm, from the foundation model, and from the data that we have pushed in, and then it generates. So this way, it is the quick, fastest way to keep it updated with the latest. Now, if you look at, if you take the GPT-4 right now, I'm sure it may not have the last month's or even 4 or 5 months back data. So is going to be Llama. The Meta's thing, they won't have the latest. So you update these data with the latest models. Okay, so core is LLM, and then you choose how you want to adapt it. So idea of adapting a foundation model through any of these methods. And prompt engineering, okay, prompt engineering is the art and science of designing and optimizing text queries, crafting text to guide LLM towards generating the desired output. So this is, of course, going to be a laborious, a time-consuming process, but the easiest way to know, at least evaluate your foundation models. And there are various kinds of prompts, direct prompts, one-shot, multi-shot. They look into various. And I said today, you have foundation models helping you to do these kind of prompt generations as well. So prompt is as simple as going into a chat, going to Chat GPT right now and asking a query. I mean, the idea of knowledge, you would know after quite a bit of learning of the whole AI space, is it's discovery, it's search. Knowledge is not an invention, it's rather getting into the idea of discovery. You will kind of learn that. So it's all, if you look at backend, it's all about a search. You are doing a search using neural networks, and then it also helps to generate. Okay, so retrieval-augmented generation, I said, is the between among the extremes. to get something up and going in the quickest possible time of a solution. So most of the solutions, 70-80% of the solutions are going towards this. However, having said that, today we've there are models that have been evolved using synthetic data, and those models seem to be giving you more desired outputs, comparing to the otherwise very generic. And so again, the data is what is the crux of this whole problem. See, let's say, if I look at an organization and they suddenly decide that or they decide that they want to develop a new application. Now, can I do that with a code generation stuff? Now, I'm talking of building a microservices which may have multiple different applications, front end, back end, generating all the business logic, generating the test code, while you are only doing an instruction to the foundational model. Now, are we ready in that state? And is it, first of all, possible? First thing is, yes, it's definitely possible. But have we reached that stage? Yeah, we have not yet, but we are definitely jumping towards that, or leaping towards it, I should say. Now this is the kind of and this generated data outright, with all tests and security checks, and it should be launched. We are talking of which otherwise would have taken 8-10 months or a year. I can do this in 2 or 3 weeks time, and that's the level that we are looking at to do. Now, of course, if you want to do something like that, we would probably need to fine tune your foundational model to be able to generate that things. So you might need to have contexts for those businesses. Okay, and this is how your RAG would look like. One important piece of RAG is there is this idea of vector database. So what is a vector database? We will come into that soon. So yeah, you have your foundational model here. There is vector database in which you add those custom data that you want to be used in the foundation, in your foundation model, and then when it works with your LLM, it is able to generate the data using the existing learning and from the present data. Okay, that's your RAG. And fine tuning, pretty simple. It's all about literally retraining your foundational model with a set of capability, that you think would add value to your organization, or I should say, it would get you more focused domains. The fine tuning is the fastest way to get, but again, fine tuning costs. It takes time. And again, the data is the most important piece, but a lot of organizations are doing this, and I see going forward, as the processing cost goes down, you'll find more fine-tuning happening. While RAG is not going to get replaced ever, RAG will not get replaced, but you will find more of fine-tuning happening, and this fine-tuned model then gets into RAG. That's the way I look at how this whole solution is going to go through. Okay, so yeah, it's pre-training is very computational. I mean, so if you don't do fine-tuning, then what is the other choice? I should say we have to build everything from scratch, which is of course going to be expensive, very expensive, I should say. So fine-tuning is a better approach. I mean a cost-saving approach, contrary to your completely fully pre-trained model. Okay, so to build applications, we need some frameworks. Generative to build or integrate foundational models to your applications, I need framework. Okay, so there are quite interesting frameworks. I mean, rather basically two of it, which are being used right now: LongChain and Llama Index. And it's through this that applications are being integrated, I should say, to foundational model. And when you're developing a RAG, or even when you're developing a prompt-based approach, you would end up eventually using application framework to integrate it. Okay, so either it's LangChain or your Llama text. And what's vector database? Okay. So vector database is nothing but when I say vector database, what it stores is for RAG. I said we need you are going to have your proprietary data to be used along with an LLM. So when I have to process my proprietary data, I said everything starts with a word vector. Everything starts with a word vector for any kind of further processing that you would notice. Okay, so I have to convert my existing data, whatever that may be. I mean, when I say data here, I'm talking of purely text. Images are done in a bit different way. I think text, you will have to have them go through a word-to-vec conversion, and that is stored in your vector database. So vector database stores word-to-vec, and then from there you are able to combine it with your foundation model. That's the way you are able to combine both of these data, and that's where the word vector database comes in. Okay, so you could actually dump anything into your vector database. However, when you are largely looking at LLM models, it's all your text that you are looking at. Okay. Now, so you can build your own service, right? You can that's what is happening. But how do you build your own service? Now, can I get my foundation model as a service? Or should I get my foundation model, my vector database, my web framework? Then to build an application, you need to have its own ecosystems, right? Which includes some observability engineering, cybersecurity engineering. All of that actually puts together and builds an app, right? So you can do that on your own, on your private, private clouds, etc. But the easiest way to start off something is using it as a service. So OpenAI, one of the first that initiated this whole stuff. They have it now. AWS Bedrock is that framework to do any kind of generative AI application integration. Now the other two cloud vendors, of course, not going to keep quiet. And of course, SDR OpenAI is nothing but rebranded or from a white label. You put a label and get it. That's here, but they're using the same thing. And Google, the original developers, creators of this whole stuff, but they never got popular the way the others have. Now, what's hybrid? Okay, so hybrid is all about using. What's happening is anything in the generative world is expensive because of the compute resources that are needed. So a lot of organizations, while leveraging public cloud, they also end up using your private cloud. So that you could get the best of both the worlds and keep your cost minimum. But this may not be the issue with large organization, but a lot of startups would like to kind of bring down your cost and things like that. A classic case to mention is this Ola's own Kutrim AI, which he has built up, right? He has also have their own LLMs that he has built for language translation, I presume that is. So you could do things like that. Okay, and this is how that whole generative AI ecosystem looks like. It's a lot of foundational models, a lot of them pretty much focused for various tasks, starting from code generation to mathematical solving to protein development, you name it. There is everything. It's massive at this point in time, and it's going to get even bigger. I would see if you look at your say this, everybody uses, right, the Office 365 stack, which has Word, Excel, and your PowerPoint. And now the present cloud it is running is a traditional, I would say, a traditional AI stack. I would call it traditional AI. Now, if you want to truly have these applications integrated to a generative stack, I think they have to build a new cloud altogether. They'll have to reimagine the way the whole O365 stack itself is to be, have foundation model embedded in there. And that's where I think there was a proposal going around saying that to build a new $100 billion dollar data center, which generally means that you may have generative, you may have foundational model equivalent capabilities right from your operating system to your networking stack and definitely onto your application. So that's a big reimagination of the whole software ecosystem which we have seen in the last 60 or 70 or odd years since the beginning of the computers as such. Okay, so what next? Now that we have seen so much, yeah, I say welcome to the world of small language models. Maybe this for another session. Now, this is what is happening, and this is a bit of research that I'm also actually doing. This is about implementing large language models into your smart devices, or rather, I should say, they were never smart. It can become smart with this particular implementation. Okay, I have a quick little, I think I have a few minutes. I'll show you a quick demo if my connection to the server is not disconnected. Yeah, I think I am good. Just to give you a quick idea how powerful the system is, and then to get you into. So this has nearly 125 GB of memory, and you look at the system. Probably, I think it has. Okay, it's nearly 24 CPUs or 48 pipelines because this is Intel. It's on this system. I am going to show you a vision model, a large vision model. However, this is not a large in the perspective of large. This is actually a small language model, which is equivalent to a large language model. And this comes from, this is a model that Microsoft is promoting in a big way, targeted towards edge computing, smart devices. In terms of power, this is as much as a Llama or your GPT-4 for general text generation and things, or even for image generation and understanding and things like that. May not be great for a mathematical reasoning, or for that matter for a code generation, etc. But there are various other purposes. These are extremely good. Your IoTs, but basically anything on the edge, anything on the smart devices. These are models, and I said these models would eventually percolate right into your Linux kernel and stuff like that. This is something that I'm working on, and I thought I'll show you something around this. You can download this from Hugging Face or from their site, and I've downloaded all of them. So it's what I want to tell you is this is a CPU version. I don't have a GPU. In spite of this powerful machine that I have, you can have a look at how this model behaves. So this is a 5.3 vision model. It's a vision model. Now, what this model has helped me to do is I'm going to give it an image, and this is the image that I'm going to give. Okay, I'm giving it an image. I'm giving it image. There is a laptop, there is a cactus, there's a pot, etc. Now I'm asking it to help me understand what this image is. Okay, so I will have to just copy that image. Okay, so I have passed the image, and I'm asking him what is that? Even the prompt sometimes. Okay, so the expected answer. I'm sure you know what it is. Now, what I'm giving an image. This is not normal scraping that you're doing through an image, right? It's not a PDF scraper and then you are getting the number to, but it is able to understand that picture. Okay, and it takes a minute or two to see what that is. While it is in process, I could just check if I have any chats that. Okay, so it says the object number 2 is a laptop. Right? This is the level of I say the intellectual capacity that has been added into the algorithm. And this is at a but you see that having such a powerful system, it took nearly a minute to kind of throw out the output. That's where you need your GPU, and it would have given you instantaneously. This is a very simple image that it can process as such. But you see now the problem of having it in CPUs. Okay. Having said that, I have seen the demo. That basically concludes my presentation. Hope you folks had a good understanding of this whole ecosystem of generative AI, and largely how you could build a skill on it for further solutioning for your organization that you work or for your clients, and self-learning as well. There are a lot of pieces that there's a lot of pieces that go into it, and very interesting. It's all about having an intellect into just a encased into a algorithm, I should say. That's all from my end. Otherwise, Ria, it's for you to take it forward from me.
Thank you so much, Rajiv, for your invaluable insights on the technology. I'm sure it was certainly a very informative session for all of you. If you guys are interested in learning more about various GenAI, do check out our super discounted batches of virtual instructor LED trainings on our website, springpeople.com. These VILT trainings are leveraged online from the comforts of your home and flexible as per your schedule and location. If you do not find any suitable batches, we'd be happy to discuss and schedule private batches for you. If you don't have time to join live online, then do try out our affordable self-paced courses. For more information, do write to us at training@springpeople.com or call on our number displayed on the current slide. Okay, thank you once again, Rajiv, and thank you everyone. We appreciate you being here. We shall be sending out the webinar recording to all you participants soon. I request you to kindly provide feedback before signing off, which will help us improve the quality of our future events. Thanks again for joining us today. Signing off on behalf of Team Spring People. Hope to see you again for our next expert webinar. Thank you.
Thank you.